All right, welcome. I'd like to thank everyone for making the time to watch today's webinar about Ubiquiti's AirFiber platform. Today, we'll be talking about AirFiber 5 and 24, their features, use cases, and some future enhancements. Before we begin, I'd like to introduce our speakers for today. First up, we have Chuck Masensky. He's a senior software architect of our AirFiber team, and he's based in Chicago. And I'm John So. Some of you may know me as JT, and I help out with special projects, and I'm based at headquarters in San Jose. Today, we also have a guest speaker. His name is Dustin Saran of Eric's Broadband, and he's the owner and operator, and he's based out in Colorado. And he's here to share some of his deployments with you today. All right, so what is AirFiber? Well, AirFiber is high-performance wireless backhaul that combines license-free band operation, advanced custom radio design, and Ubiquiti's unbeatable price to performance. So, what does this all mean? Well, it means that AirFiber is designed for freedom. As you know, we operate in the 5 and 24 gigahertz spectrums, and that means that there are no special permits or paperwork, or no added licensing costs when you deploy. You are free to locate and operate AirFiber practically anywhere you choose. And that also means that AirFiber is efficient by design. When the AirFiber team started this project, they started from a clean sheet of paper, and that resulted in a custom silicon chip, single-piece integrated radio, and high-efficiency over-the-air protocols. And as a result, AirFiber is built for speed and range. And we achieve that through scalable bandwidths, the fact that AirFiber is frequency agile, AirFiber has spectral efficiencies greater than 15 bits per hertz, and we achieve link distances over 100 kilometers. AirFiber also features half and full duplex operation, and let's not forget the unbeatable price from Ubiquiti. At this point, I'm going to hand it off to Chuck Masensky. He's going to talk through some of our hardware and software features, as well as talk about some future updates that we're going to have with AirFiber. Chuck?
Hi, thanks, JT. Well, good morning, guys and girls. I guess I'm going to start by the unique look of an AirFiber. This is the dual antenna architecture, which you've seen. This is for an AF24. And we get a lot of questions as to why it is that why we have such a unique antenna, and I just thought I'd touch on a few of them so people have an idea of the kind of design work that went into the AirFiber product line. First of all, by having a fixed antenna that's integrated with the unit, in addition to the efficiencies of the coupling between the radio and the antenna, we're also able to very accurately characterize its isolation. And what this allows us to do is actively cancel any sort of TX signal that may have found its way into the RX antenna. So when the AirFiber unit is transmitting, it's also receiving in the full duplex mode, and it is actively canceling any signal that might have leaked from the transmit side to the receive side. It also ensures that we have very accurate receive and transmit path alignment. That's very important because it ensures that we have path reciprocity, which is needed in order to get the high modulation rates that AirFiber supports. Finally, this antenna supports something which is a little unusual. That's slant polarization. We're a two-chain MIMO radio. However, rather than doing vertical and horizontal polarization, which is pretty typical out there, we're using slant polarization. And the reason for that is that it helps us better isolate reflected signals. As a result, it takes advantage of the fact that a lot of the reflective surfaces that you'll see out there are either horizontal, like the ground, or vertical, like a building. But when you put this all together, what it adds up to is excellent full duplex performance. So excellent, in fact, that we are the first affordable solution that supports 1024 QAM. We are by far the least expensive 1024 QAM link on the marketplace right now. And in our 5 gigahertz product, we're able to support 1.2 gigabits per second aggregate as a result, which is really pretty impressive given it's merely a 50 megahertz wide channel. as I mentioned, we support full duplex and half duplex as well. Here are a couple of typical configurations. Um, Typically, in a half duplex setup, you would see that we'd be using the same frequency for receive and transmit. And typically, on a full duplex radio, you'd be using different frequencies. There's actually no requirement for that, as both modes can be supported whether you're in full duplex or half duplex, but this is typically what you see. A half duplex AirFiber radio is capable of about a 2 millisecond latency, which is very good, and it's better than you're going to find typically with Wi-Fi products that have been converted for outdoor use. However, where AirFiber really shines is in full duplex mode. In full duplex mode, we're able to get latencies down to 200 microseconds. We get roughly twice the capacity because you're transmitting and receiving at the same time. And it also supports something called non-symmetric bandwidth usage. And what that is in a full duplex link, you can set one direction to be a very high, utilize a lot of bandwidth, say a 50 megahertz or 40 megahertz channel, where you have a lot of data to push in one direction. But on the channel coming back, you may not have as much data. And so for that channel, you can set it up to use, say, 10 megahertz of spectrum, making the AirFiber a very spectrally efficient radio as well. AirFiber is also a pretty wide band radio. We don't have frequency-specific pairs. For people who are familiar with a lot of the licensed backhaul products, when you order the radios, typically you'll have to order what frequency or narrow range of frequencies that you're planning on using the radio link. And they need to do this because for those radios, there's actually a hardware-specific filter that gets plugged in. There is no such limitation with AirFiber. An AirFiber radio covers the entire band that the radio covers without any sort of hardware modification at all. There really are no frequency-specific pairs. Now, for the AirFiber 5, we actually sell two units. We sell an AF5 and an AF5U, and the AF5U is capable of going a little bit higher in frequency than the AF5, and the AF5 is capable of going a little bit lower, but both of those radios cover a very, very wide band. And in fact, you can have an AF5 talk to an AF5U as long as they're using the frequencies in that shared band space. To give an example of the types of things you can do with AirFiber, we have a sample here where we actually had the case I talked about, where you have a link that requires a lot of bandwidth in one direction, but not so much in the other. This might be a feed to a whole field of access points to somebody who maybe is running a web server or a server farm and it has to push a lot of data in one direction, but doesn't quite have the same requirement in the other direction. In this particular case, we're using the 5.8 gig because that's a high power band where we can push a lot of data in one direction, and we're using the 5.4 band, which is a lower power band as a result of DFS limitations coming back in the other. And we've split the bandwidth such that the 5.8 band is taking 20 megahertz spectrum, while the 5.4 band is taking only 10. We've also done one other thing here, and that is we're using different power levels in each direction. So the 5.8 band, which requires a lot of data throughput, is running at a 43 dBm output, allowing it to do 8x modulation, whereas the back channel doesn't require nearly as much, so we've been able to turn the power down to 27 dBm, and that one is running at 2x modulation. Basically, this provides asymmetric bandwidth. It's incredibly bandwidth efficient, and it's a pretty typical installation for AirFiber. To give you an idea of how AirFiber performs against a rocket or other Wi-Fi adapted systems, in the field we typically see a 10 megahertz channel AirFiber unit is equivalent to a 40 megahertz channel Rocket M. And this is actually a TDD comparison, to be fair, because the Rocket M is running Wi-Fi, which is a TDD radio, either talking or listening. And in this case, that's how we've configured the AirFiber as well. some of the ways we do this, or the reasons we're able to do this, it's not magic, is that we've designed the proprietary MAC from the ground up. And that MAC was designed for outdoor usage. So there are a lot of things that an indoor chipset takes advantage of, especially when you're inside of a building. But these are propagation characteristics that don't typically exist on the outside. And so we've optimized our system for operation on the outside. Also, all packet handling that happens inside the AirFiber is all handled in hardware. The CPU is not directly involved in handling packets, so there's essentially no limitation in the packet per second performance of an AirFiber beyond what the air signal is actually capable of handling. Run on some software features here, and I apologize for dumping so much data, but I could go on for a long time on these topics, and I'm trying to get a lot into a small period of time. This feature we like to call Link at a Glance, and what this feature lets you do is it lets you take a look at any screen on an AirFiber and almost immediately determine whether or not it's well aimed. Basically, all well-aimed links will show what you see on the screen here, which is that color bar graph going all the way out to blue. And we do that by actually calculating what the expected received signal is, taking into account the power level, the frequency, and the link length. This will support mixed power levels, frequencies, bandwidths, whatever. However you configure that link, the AirFiber, when it first establishes a link with the far side, will determine what signal it should be receiving and will scale the bar graph accordingly. For those who are in the field who are aiming the unit and don't have access to the web page, there are also other options. They're not really shown here, but the AirFiber units all have an integrated RX power meter, which is calibrated. It's a 7-segment display, which shows you the receive power at the radio. And they also have an audio aiming tone, which allows you to plug in an amplified speaker or a headset, and when you adjust the radio, you can, through just the tone, you can tell when you've got a good link, which also dramatically speeds the aiming process. Now, because the AirFiber is so flexible, it turns out there are just, I won't say an infinite, but there are a very, very large number of configurations possible. To try to simplify that and allow someone to come down to an actual configuration, we've created the AirFiber link calculator. Now, this calculator is integrated into the web page of every AirFiber 5 unit right now. And what it does is it allows you to put in parameters such as the link margin, the range, how much bandwidth, and by bandwidth I mean actual delivered data that you need to provide with for the link. And then this will go back and it will calculate for you what the ideal frequency, or not frequencies, but what the ideal, that would be nice because frequency blending is somewhat complex, but we don't have that integrated yet. But it will let you know what the minimum bandwidth you can use is and at what power level you need to use it in order to get the required capacity through. And that also takes into account margin, the C to I, sensitivity of the radios, any sort of pre-distortions that we do in order to create the linearities needed for the transmit and receive. Just all sorts of characteristics. The entire radio model is actually integrated into this tool. And so we actually have, and it's an example here, we had a link where we were running at a 5.8 gig and a 5850 gig were the frequencies we had available, and we needed a capacity of 50 megabits in one direction, 400 in the other, and this would be for a 5-mile link with a margin of 6 dB. If you put all those things in and you push calculate, what it comes back with is it will tell you how much bandwidth is needed in each direction and at what transmit power level you need to set the radio. And then it also provides you with the expected capacity if you set all those parameters and you have a well-aimed link. That saves just an immeasurable amount of time in terms of configuring the radio. And it also gives you a chance to take a look at it, maybe a link you're thinking about, put the parameters in to determine exactly, for example, how much bandwidth you would require to pass that much data. Next, we have a capacity graph, and this capacity graph shows up on the main screen of every radio, and what it shows you is the actual data capability of the link at any given moment in time. This is essentially a real-time link test that is always on and always telling you what the link performance is. The way it does this is that any unused data slots that aren't being used to carry user traffic are filled with a pseudo-random pattern. And the radios on the far side, the receivers, are decoding that pattern along with the user data and determining exactly how much data they were able to receive. And so what that gives you is not just an estimate, but it actually tells you how much data was passed over the link at any given time. So by using this, you can take a look and very quickly determine how much bandwidth you have, if the link has been degraded for some reason, maybe a tower fell over or some event that you didn't anticipate, but you can see it right there all the time. On the cabling side, it turns out that one of the things that we've learned is that when you look at a large network, one of the most common problems you find turn out to be issues with cable. And unfortunately, running long runs of outdoor cable up and down towers is no different. And so what we've done is we've integrated in a time domain reflectometry system that actually measures and rates the quality of your data link cable. In this case, we have, if you look at the top blue square, we have a link that is running, and it's actually an RF link. But on the far side, we've disconnected the data pair. So you have a cable that's running from the radio down to the power injector, so it's got power. But then the cable coming from the power injector has just been disconnected. And so what this shows you very quickly is that on the right-hand side, you can see all four of the data pair show an open at about 200 feet. And so what you're looking at is about a 200-foot cable down to a PoE, which has then been disconnected. And so if you're installing a link or trying to debug a link, you can look at this web page and immediately determine, someone pulled the cable out. Again, now on the bottom, we have a similar link, but in this time we're actually connected up. And you can see that the cable length is less than 20 meters, so this particular one is very, very short. And on the right, you see the relative signal-noise ratio that the transceiver is actually seeing, the chip that actually decodes inside the radio. And so this is the signal-noise ratio that is seen after the internal AGC. So it's sort of a relative number, but it tells you what the chip is seeing. And at 28 or 29, I believe, is as good as it gets. And typically, you'll see numbers in the 28 range for links where you don't have any sort of an issue with the cable. But what these two tools give you, after all the engineering gobbledygook that I've just spilled out, is they give you the ability to simply identify if you've got a bad cable, if you've got a bad crimp on a cable, or just a bad pair. And that's all simply by just looking at the front web page. Finally, the last thing I'm going to talk about here is a carrier drop feature, and this is something that's fairly new. What this feature allows you to do is it allows the Ethernet carrier coming from the data port of the radio to track the RF link. And you say, well, gee, why is that important? Well, that's important because I would say most, but a large number of carriers have a redundant system in place. They have a ring system, or they'll have multiple links to multiple destinations. So if something were to happen to a tower, the entire network wouldn't go down. The way this is typically done is through routing protocols, OSPF being one of the most popular ones, where OSPF will monitor the link and determine if there's a problem. And if there is, it will actively reroute the traffic around that problem, allowing the network to stay up. However, OSPF can take a while to determine if a link has gone down. So with this feature, if something were to happen to the RF link of an AirFiber, it can immediately drop that carrier so that the OSPF router can then immediately route the traffic around. The typical case you'd see this used for would be something that would be simply, it would track the RF link up and down. Right now we've added a feature here where, and it's sort of displayed here, we're saying use timeout duration, where we are dropping the link, but we're not going to drop it for as long as the radio link is down. We're just going to drop it for 5 seconds. And then we're going to leave it up for the next 85 seconds. And the reason we're doing that is for some operators, they will manage these radios in band using the same cable that's carrying user traffic. And if you're doing that, when the RF link has an issue, that's not the time when you want to lose the ability to manage the radio. So what this allows you to do is to drop the carrier for just long enough for your routers to pick that up for user traffic to be rerouted, yet for the most part it's up, allowing you to go in and manage the unit. Something that we haven't really talked about yet, but it will be coming up in a fairly soon future release, is we will also be adding the ability to support dropping that carrier based on a loss of capacity or modulation rate. So rather than being an all or nothing, if something were to happen that would degrade the link, the OSPF routing system would be able to kick in and route around the link while you determine what's actually happened.
All right, Chuck, thank you so much. So right now we're going to go take a look at what we currently offer on the AirFiber platform. Right now we have two flavors of AirFiber 5 and one version of AirFiber 24. With AirFiber 5, we have AirFiber 5 and AirFiber 5U, and both of them operate in the 5 gigahertz band. As Chuck mentioned earlier, the AF5 operates in the mid-range of the 5 gigahertz frequency, and the AF5U operates in the upper part of the 5 gigahertz frequency. Both of them can reach out to over 100 kilometers. Both can push up to 1 gigabit per second, and both feature less than 1 millisecond latency. You can get it for $999 per side or less than $2,000 per link. AF24 obviously operates in 24 gigahertz, but as a result, because it operates in that spectrum and that frequency, the links are about over 13 kilometers, but because of 24 gigahertz, we also get faster speeds at 1.4 gigahertz per second. And just like AirFiber 5, it also features less than 1 millisecond latency. It's $1,497.50 per side, or less than $3,000 per link. All right, so let's get into some of the case studies. Before we get into them, let's talk about who uses them and what do they use them for. So we've seen carriers and telcos use them for voice and data, wireless ISPs using them as primary backhaul links, municipalities, hospitals, and banking, we've seen them using for high importance connectivity. And for schools and universities, we've seen them use it as cost-effective backhaul. They have a budget to work with, so AirFiber is a great solution to get internet to the school. And then finally, in hospitality and multiple dwelling units, we've seen them use them for general connectivity. So our first case study features AirFiber really showing off its ability to push an amazing amount of throughput. And our first case study is a hospital link in rural California. And they had several challenges. So once their wireless link went down, they had some issues. They realized that it was too far to run copper coaxial with fiber, and the hospital also had increasing bandwidth needs. In the hospital, they had these telemedicine cards that require a fair amount of bandwidth, and they were adding a second one. And the hospital also was in the process of upgrading the VoIP. So AirFiber was a great solution, and as a result, they were able to push 1.2 gigabits per second, and that's more than enough bandwidth for their future needs. Here's a screenshot of their control panel, and as you can see, both the transfer and the receive are just under 620 megabits per second. And here's the other side of the link, and as you can see, the receive is actually above 620 megabits per second. This second case study is about flexibility, and I'm actually going to hand this off to Chuck to walk through it. Chuck?
Okay, thanks. Basically, this is another scenario similar to what I talked about, where we have a mixed frequency, mixed bandwidth, mixed power system. In this particular case, we needed a lot of bandwidth in one direction, not a lot in another. And so what we have here is a system where we've got a TX channel width configured for 20 megahertz, receive on 10. Our transfer frequencies and receive frequencies, as you can see, are split across the high band and the low band. And that gives you what you see on the screen here, which is if you look at the lower right-hand corner of the capacity graph, you'll see we've got 21 megabits per second in I'll call it the back channel. And in the main channel, where you're pushing all the data, you've got 194 megabits per second. And you have that all stuffed into 30 megahertz of bandwidth with about a 200 microsecond latency. it's not part of the flexibility, but you can also look, if you look in the Ethernet stripe over there, you'll also see that we've got an excellent cable, which is important whenever you're trying to pass data, making this just a very flexible solution.
All right, here's the map for that one particular link. And our third case study that we're going to show off today is one that really features off the distance that you can achieve with AirFiber. So in this one particular link, the operator had to connect two tower locations to one another. The challenge was that they were over 100 kilometers away from one another. To add to the challenge, there were also 40 microwave dishes, essentially creating an incredibly high noise environment for one of the tower locations. But AirFiber stepped up, and as a result, they were able to reach out to the other tower location. They achieved it with 20 megahertz of channel, and they were able to get just under 100 megabits per second for the transfer and just under 20 megabits per second for the receive. Here's their control panel. And as you can see, yeah, the distance actually achieved 103 kilometers. Absolutely amazing. All right, at this point, we'd like to introduce Dustin Saran. He's the owner and operator of Eric's Broadband, and he's based in Colorado. Dustin, would you mind unmuting and hopping on, please?
Sure, thanks, John. Good morning, everybody. So a little background on our company. We're a small wireless ISP out here in Colorado. I say small because we have two of the largest ISPs that we also compete against. The first link that we're going to show you is a company called Master Magnetics. Some of you may know them by the magnet source. We do their main office here in Castle Rock, Colorado, and they wanted to expand into a SIP application. So they asked us if we could service their shipping and storage building, which is about 30 miles away. We were kind of shocked that it was so far away, and we kind of told them that we didn't have any towers or assets out there that we could get them with. They had a current provider that was using a canopy system. However, the latency on it was higher than what they wanted because they were moving to, again, a SIP application. And then also they were running into capacity issues. So they ended up coming back to us asking us if we could come up with a solution for them. So every good link like this starts with Air Calculator or AirLink. I don't know, John, is there a way that we could post a link for everyone?
Yeah, absolutely. We can post it afterwards.
Okay. So those of you that aren't familiar with the tool, it's a good way to plug into different locations and see if you can feasibly make the shot. So that's really where this link started. We initially promised them 25 megs. We were a little concerned because once you start to get out of 30 miles, you start to run into the curvature of the Earth, which starts to impact your Fresnel zones. So in picking the location, we ended up picking a very high elevation where one of our other towers were. So like I said, originally they were about 30 miles away, and when we mounted the actual gear, the link, the tower was about 7 miles away from their original building. So the link ended up coming out about 37 miles. You can kind of see in that picture there, we have the AirFiber, and then in the background, or foreground actually, you'll see like a radio waves dish with a Motorola Orthogon on there. There's about 6 Motorola Orthogons on there. So we were concerned the band was going to be heavily saturated. But we went ahead and aligned it, set it up, and on the next page we'll show you what we ended up getting. So this was the complete distance. I think we had about 4,000 feet in elevation drop, so you can kind of see the terrain there. It goes from the mountains down into the plains. And then on the next screen here, you'll see our capacity. So we were only shooting for about 25 megs. We ended up getting about 140 on both sides. We're getting great decode rates on both sides. Another feature set that we liked with the AirFiber, some of you may be used to using the AirMax lines where you pick one frequency and you're transmitting and receiving on the same frequency. So on the master side, the 5/8 band was really saturated. So we ended up using that as our receive frequency. And the reason why we did that is we can power through on the transmit side through that 5/7 band, and then on the other side, the 5/8 band was really clean to listen to. So for those of you who have ever run the spectrum analyzer, you'll notice that on the master side or AP side, you'll find some clean frequencies, but on the station side, you don't necessarily have the same clean frequencies. So you can kind of mix and match on your transmit and receive frequencies. So that was just one way that we used AirFiber. The next way is we did a link to Longmont Ford. This is a dealership out in Colorado. It's about 50 miles total difference from Master Magnetics. So the one thing that's nice about the AirFibers, it's a great way to expand your coverage. You know, traditionally we would only serve customers about 10 miles out from one of our tower sites. So it enables you to get a longer reach to get clients that you normally wouldn't be able to get. So some of the challenges that we faced at Longmont Ford was they had Comcast, they had Skybeam. For whatever reason, Comcast, they were having a lot of reliability issues. It was dropping out constantly. Skybeam was using a Cambium product, and they could only get a total of about 5 megs of true throughput on it. So we came in as a third solution provider. So not only were we able to give them the reliability they needed, but we were also able to give them the capacity that they needed. So they were thrilled. So the reason why they really needed this is they have about 140 phones total in this dealership. They have about 37 service bays for trucks. They sign contracts. The service techs are constantly looking up schematics and data on trucks, vehicles, flashing firmware. They have a direct link back to Ford. So you can kind of imagine if they lose their internet connectivity, that dealership's dead in the water. So they realized the importance of it, and so did we. So that's another reason why we ended up going with the AirFiber product line. We can see some screenshots here on the next slide. So you'll see that it's coming off almost the same tower that we have in Colorado, and then going about 27 miles north. So here's some screenshots of the actual radio. You can see that we're getting great modulation rates. We had dropped them down to about 25 megs because that's what they were paying for, so there was no need to use the additional spectrum. But you'll notice that we're only using about the 10 meg wide channels. This link can do certainly more, but that was one of the nice things is as their needs expand, we can also expand that capacity without having to roll a truck. Just a few clicks and we can open up the radio. A few things that we've really appreciated about the AirFiber product line. Initially when it rolled out, I think it was the AirFiber 24s, we had set up a backhaul link for one of our towers. We're getting about 640 megs each way, so about 1.2 gigabits of aggregate traffic. We were thrilled, and you know, who doesn't like a good solid link like that? I want to say it was 2 months later, and Chuck might correct me, they came out with new firmware and they were able to fit in more data rate modules into the radios. Well, essentially what that equated to was another 100 megs. So now that same link, just with a firmware upgrade, is now running about 740 megs in each direction, or about 1.5 gigs. With any other company, you'd end up having to pay for a license unlock feature, or you would have to pay for the new firmware upgrades. It kind of shows you that Ubiquiti is really standing behind the product line and behind the people that use it. That way, as new feature sets come available, they really implement it. Same is true with frequencies. Once these devices start to get certified for other frequencies, you don't see a service charge or an unlock feature like some of the other providers end up doing. You just see the new frequencies show up in the new firmware. So that'll kind of conclude everything that I had on these two links. I'll turn it back over to John, and I think he's got a question and answer for everybody.
Dustin, thank you so much for this. All right, so we're going to open it up to QA right now. Austin from our forums has been collecting some of the questions, so I'm just going to quickly take a look over, and we'll answer them one by one. Chuck, are you available?
Oh, yes, I am.
All right, great. All right, so the format will be I will go ahead and ask the question. Chuck, you go ahead and answer. Is that okay?
If I can.
All right. All right, so the first question will be, what about performance in heavy rain or fog? What's the difference between 5 gig versus 24?
Okay, there is a bit of difference there. The 24 gig spectrum is sensitive to high levels of humidity, which is rain. I don't know that fog really has much of an impact, but rain does. And so if you're in a particularly wet climate, and that's something that you find out by looking at, there are maps that give an idea of what the how much rainfall that you'd expect to see in a given year. If you find yourself in a not very dry climate, then probably the 13-kilometer number for the AF24, which is 8 miles, that's probably a little long. You probably want to keep it quite a bit shorter than that. I think anything under 2 miles can't be killed by no matter how much rain falls. And so it's somewhere between 2 and 8 miles if you're in a heavy rain zone. If you're someplace where you don't have a lot of rain, it's fairly dry, then there should be no problem going out to the 8 miles with the AF24. The AF5 really doesn't have that issue. 5 gigahertz is really not affected by rain. I'm not going to say that obviously if a glacier came between the two units, there might be an issue, but short of that, you really wouldn't expect to see any sort of an issue when it comes to fog, humidity, anything like that with the 5 gig product.
All right, thanks, Chuck. All right, let's take a look. Second question. All right, the second question we're going to ask, and Chuck, let me know if you want to pass on this. The second question was, okay, 5 gigahertz was the first step, but when can we see a 10 gigahertz or 17 gigahertz solution?
Wow. Well, that's an excellent question that I'm probably not going to answer in any kind of a direct way. We're a development and a research group over here, and we work on a lot of radios, and which ones actually make it out through the manufacturing process and actually out in the sales force is as they politely say, above my pay grade. And so I can't really answer that. You can keep asking the question, but it's not really a question that, as an engineer, that I can talk to.
All right, thanks, Chuck.
How's that for a good non-answer?
Well, I surely appreciate your effort in trying to attempt to answer the question.
Well, people ask questions all the time about where we're going and what products are coming out, and it's really hard to be here and working on all this stuff, and because you want to talk about it, you really do, but at the same token, you can't we can't talk about things that might not happen or things that we don't know what the time frames are, because then people start planning for things, and it gets kind of messy. So for all the people who have asked me on the list questions like that, I apologize in advance, but I really can't answer that until we have a really good idea that when it's coming out, when it's going to be available, so that when people are planning to use some product that we're working on, that it's actually there for them on time. And we are working very hard to make sure that that certainly going forward, that anything that you hear about from us is there when you expect it to be.
Cool, thanks, Chuck. All right, our next question. Are there any plans to add SFP ports with DC power input terminals?
It kind of falls into that same zone. I will say we've talked about that. There's a trade-off there in terms of cost, and that we continue to struggle with because obviously while we strive for very high performance, and as an engineer, I would just push down that path as much as I could. There's also a price component, which is very important as well. And so I will say that those have been considered, and I would say at the moment I wouldn't see something in the near future, but I wouldn't give up on it, but I can't really comment beyond that.
Cool, thanks, Chuck. All right, the next question will be a combination. One of the users asked, what is the longest distance you have checked with AirFiber on a working point-to-point link? I think we answered that with our case study. I believe it's 103. Is that correct, Chuck?
Yeah, that pretty much that passes the 100 kilometer mark that we say. I don't know of any link that's longer than that right now.
Right. So I think the second part of the question is at that distance, what is the speeds you have seen?
Well, the link that we saw there, and it had a little bit of a balance issue, but we saw there was about 100 megabits per second in one direction and just under 20 megabits in the other. I'm not quite sure why it wasn't 100 balanced. I expect that with enough tweaking in terms of altitude of the link, we would expect to see, roughly the 100 megabits per second in both directions. I think that the case study there is an excellent example.
All right, thanks, Chuck. All right, next question is AirFiber only line of sight? Can it be implemented in non-line of sight?
No, AirFiber is line of sight. One of the things when you're designing the product that's different between an indoor product and an outdoor product is that a lot of indoor products can count on the fact that there are going to be reflections, and so that which is a great benefit if you're indoors. However, in the outdoor line, especially for any kind of distance whatsoever, you really don't see any reflections. You don't. So when you hear about these high MIMO or MIMO rates, in the outdoor environment, you kind of have to take some of that with a grain of salt because you just don't have tons and tons of reflections. 5 gigahertz and 24, even more so, are really not frequencies that tend to propagate around things. And the reasons for that basically have to do with the wavelength. If you have a very long wavelength, say something running very low frequency, say around a gigahertz, something like that, then you have obstacles of a certain size that won't be affected by the field won't affect them. Right, the field will go by, it'll see that, it'll rebuild on the far side of say a tree or a building and keep going. As those frequencies get higher and those wavelengths get shorter, the size of an obstacle that can be easily just gone around shrinks. And so the benefits are you have small antennas for highly directional antennas, things that don't weigh a lot, things that are very small, and to some extent there's actually an advantage to the fact that things don't propagate everywhere because it doesn't pollute the spectrum. However, the downside to the higher frequencies is that they pretty much are all line of sight.
All right, thanks, Chuck. The next question is, can you please tell us the recommended method for aligning longer distance deployments?
Wow. Well, yeah, I can. I think it's written down. I'm actually not the RF guy, and so if I'm about to give you a procedure, and if it is wrong, I will post that I was wrong on the forum after I talk to one of the radio guys. But basically, what you want to do is you want to align the receivers here, and so you end up with the two units initially mounted in a generic close to direction, and then on one unit you want to basically scan it. You want to go up and down, left and right, and if you can imagine kind of pointing it into like a grid, an imaginary grid that's in front of you. And what you're looking for is the strongest received signal. And when you find the strongest received signal, you lock it down, and then go to the far side and do the same thing. And it's important to scan through the entire grid, the imaginary grid, and the reason it's important is because with any directional antenna, any high gain antenna, you will have lobes. That's just physics. And so you'll have the primary lobe, which is what you're intending, right? That I'm intending to aim that, and that's dead center, and I've got my antenna pointed the right way. However, several degrees off of those lobes are going to be sort of, I'll call them like fake lobes. They're actually places where the gain is higher than you'd like. It's higher than a null, right? However, it's not the highest gain lobe. If you just scan small directions and you think, hey, I found the strongest signal, and I go back and forth a little bit and up and down a little bit and it gets weak, you can fool yourself into thinking that I'm actually using that main lobe, right, the one with the highest gain. When in point of fact, you could actually be connecting to a side lobe which has gain, so as you move it you'll see the signal go down, but not nearly as much gain as the main lobe will. And so you end up on one side scanning the grid, locking it down, and on the other side doing the same thing. One other thing that really helps is if you are using the audio aiming tone, and I've watched people do this on water towers and other places where you, actually water towers are actually pretty, it's a pretty nice place to stand if the weather is good, but by plugging in this audio tone, you can in real time hear exactly how the thing is aimed. So you don't have to wait for like the LED display to update, which is I think every 200 milliseconds, so that's not too bad, or the web page display to update, which takes a little bit longer. You can actually scan that grid, and you can just hear where you're getting good signal and bad signal. And when you go that route, it becomes almost immediately obvious where the main lobe is when you go to aim the thing. And so I think that's in a nutshell the way you go to do that. Obviously, if you're trying to aim a 50 or 60 mile link, you really better know, have a good idea of what the angle is or where you're pointing it, because some of those things are so far away that you want to start with something that's fairly close.
All right, thanks, Chuck. All right, the next question is there a minimum distance for AirFiber?
Well, actually, for the AirFiber 24 there is, and for the AirFiber 5 there's not. That does remind me about something I didn't talk about back when we were running through the slides. If you remember, and it's not important to find the slide, but if you remember, you would see that we seem to show a path going from the bottom dish, which is our transmitter typically, to the top dish of the far side. And so it looks like they crisscross in the air, which I guess technically they do, but you never really have to think about that crisscross, that physicalness of it, as having any impact. And that really is not the reason that we have a distance limitation on the 24. The 24 itself is capable of quite a bit of power, but there's a thing in radios called the received dynamic range, and that has to do with the strongest signal versus the weakest signal that you can receive. And in the AF24 case, by the virtue of designing a radio that runs in the 24 gig bandwidth, that is somewhat limited. So the closest in link you can set up in AF24 is about 100 meters. And at 100 meters, you have to set the RX gain low, which helps put an attenuator in front of the receiver, and turn the power down to about 10, maybe 12 dBm out. And then you should be able to run about 100 meters. We actually have a link like that running on the roof of our buildings here in Barrington. For the AF5, however, the dynamic range is much larger by virtue of the way you can design a 5 gigahertz radio. So for that radio, there really essentially is no range limit. However, I would caution neither of these radios is really designed to be used indoor. And so when I say that it's, you don't really have, there's really no distance limitation for an AF5, that doesn't mean that you can take two AF5s, put them 10 feet apart inside, and know for sure that they're always going to work. They may well work, but they may not. And if you have issues, what you're looking at are reflections, internal reflections, like off the roof of the building, off of if there's rebar in the cement in the floor, cue balls, whatever. The indoor reflection characteristics are vastly different from outdoor. And so we take advantage of those features to make a very high-efficiency outdoor product, but as a result, it doesn't do as well indoors as a Wi-Fi product by any measure.
All right. Chuck, the next question is, AirFiber 5 has 1024 QAM. Why does not the AirFiber 24?
Well, that's a good question. The AirFiber 24 radio is a significantly different design, and some of the characteristics of 24 gigahertz made the hitting the numbers, having the signal integrity required to decode at that rate, very, very difficult. We do have in the lab, and I don't want anyone to get excited about this and say, oh, Chuck said they're about to do this, because Chuck's not saying that. In the lab, we do have links that are running at 256 QAM, and we have played with 1024 QAM, even at 24 gigahertz. However, it's very difficult to build a radio up in that frequency band inexpensively that's capable of repeatedly doing that. And so we do have some radios, specific radios, that are capable of doing that in the lab, but it's not something that we can manufacture in large quantity and be able to control so that we can guarantee that every radio is going to operate there. And in fact, I would say the majority of the radios do not operate where they would be able to hit 1024 QAM, and that's sort of a trade-off between a $3,000 24 gigahertz link, and a $10,000 or $13,000 link. If we could spend more money on the radio, we might be able to do that. However, the trade-offs just didn't make a lot of sense while we were designing the radio.
Cool, Chuck. We're going to take 2 more questions. The next question is, and I think you already answered part of this one already, but the second half I thought was worth bringing up. So the first part of the question is asking about new frequency bands, and we've already touched upon that. But the second part of it is, what about enhancements to the existing products? For example, higher constellations, lower power consumption, et cetera, et cetera.
Well, we're always enhancing the product. I mean, some of the features that we showed with the TDR, time domain reflectometry, sorry, on the Ethernet cable. I mean, these are features that don't exist, didn't exist in the initial release, as well as features you're going to see coming up on the software side. So we are always adding features there. When it comes to features like power consumption or constellation, you really start talking about a different product because there are reasons that these radios consume the power that they do, and there's really not a lot we can do given the design of the radio. To operate at 1024 QAM at these very high constellations, one of the things you need is very, very good signal integrity on the transmitter. People think about, well, we pick up a lot of noise, and you've got the receiver, and it may be picking up noise, and maybe that's why we can't hit that. But the transmit side also has to have really good signal integrity, and the way you get that is with very linear power amplifiers. Unfortunately, for those of you who maybe are familiar with radio design of OFDM radios, you end up having to have a fairly wideband amplifier that is very linear, and almost by definition, those things consume a lot of power. And so when you look at the power consumption of the AF24 or the AF5, really a lot of that power is going into the linearity of the PAs and what you can do to get a high quality output signal. Clearly, if we put larger PAs on, which would be a different product, you would be able to get higher constellations, but you would also have a higher power draw. And right now, the power draw that we see coming in over the PoE is about as high as we're comfortable with at the moment. I'm not going to say that we couldn't go higher, but I would say that at the moment we're not really comfortable going a lot higher with a PoE solution, which, the PoE solution is great. It makes it easy to install, and it also helps make the radio less expensive.
All right, thanks, Chuck. So the next question is, are there any plans to take AirFiber technology and applying point-to-multipoint deployments for last-mile wireless connectivity? And before I let Chuck go ahead and answer that question, I'd like to mention our point-to-multipoint AirMax offerings, and you should definitely take a look at that. But Chuck, do you mind answering the question?
That's a question I definitely can't answer. We are researching many things, and that's as far as I can go with that, or someone will shoot me.
Okay. Um, since that one was a mulligan, we'll answer one last one. And the question will be, what type of latency can I expect in AirFiber 5? Let's use 20 kilometers as an example. And how does this compare to 802.11ac? In this particular application, he does not need that much bandwidth, but he's sensitive to the latency.
Well, the latency, I think, in AirFiber is always going to be better than an indoor protocol that's been modified for outdoors. But to underline that a lot, if you're running a full duplex AirFiber link, we're talking 200 microseconds of latency plus the air delay time, which is the speed of light, right, going between those radios. And I have yet to see anything Wi-Fi based ever that could repeatedly deliver anything even vaguely close to that in terms of latency. So for gamers or people who are sensitive to latency, AirFiber in a full duplex configuration is going to be very difficult to beat, even with far more expensive links.
All right, Chuck. Well, that concludes our Q&A. Chuck, thank you so much, and I'd like to thank everyone for joining us today for this webinar. I know your time is very precious, so hopefully you gained something, hopefully had some questions answered. For those of you who didn't get your questions answered, feel free to email us at sales@ubnt.com. And for those of you who just want to go ahead and ask questions on our forum, again, we have a very vibrant community, and everyone's very, very helpful and very friendly. And if you just want to check out some additional AirFiber case studies and other deployments and successes, go to community.ubnt.com. All right, that concludes everything. Thank you so much for joining us, and we hope you join us again in the future for some additional webinars. All right, thanks so much. Goodbye.